Okay, so we're going to follow up our special parallelogram notes from yesterday with your flip books. So if you would get out your flip books, we're going to get started right away. So it says properties of rectangles, and what we want to review is that rectangles are parallelograms. So rectangles will have the properties of a parallelogram like we talked about. So just reviewing those properties real quick. It says opposite sides are going to be parallel. Opposite sides are going to be congruent. Opposite angles are going to be congruent. Consecutive angles or same side interiors are supplementary. And remember, supplementary just means that they're going to equal to 180 degrees. Okay, and then the last one is the diagonals bisect each other. So those ones aren't new. Those are just review properties, okay? The two new ones for rectangles, one of them is the definition of a rectangle. So definition of a rectangle is that it has 4 right angles. So we're going to fill in that it has all right angles. And we can see on this diagram up here that it has all right angles because they're all marked as 90s in the corners right there, okay? The other thing that is new specific to rectangles is that the diagonals have to be congruent to each other. So that really means that the diagonals will have the same measure, but they also bisect each other. So remember, all these smaller pieces are the same here, okay? When we work with some of the example problems for the rectangles, like right here, it says if JKLM is a rectangle, find each missing measure. So just kind of applying those properties, it's asking for KL, and this side right here should be the same as JM, so I'm going to fill in 25 for KL. NL, if you look, NL is going to be this segment right here. Can you guess which one it's the same as? It should be the same as NJ because the diagonals bisect each other. Okay, the next one, KM. KM is going to be this full stretch right here, this diagonal. So if you think back to what we just said, NL is 13 and JN was 13. So this whole diagonal right here, JL would measure 26. And on a rectangle, since the diagonals are congruent, then I want to fill in 26 for KM as well. Okay. Then from there, what we're going to look at is we're going to look at the angles. Oops, excuse me. I did not mean to do that. Let's see if I can delete it. Okay. I went to erase and I accidentally drew a circle for us. Okay, so here we go. From here it says to find the measure of angle KLM. So if I kind of trace for you guys, KLM is going to be this angle right here. It's one of the main angles of the rectangle, so it's going to be 90 degrees because it's all 4 right angles. The next one says angle LMK. So if I trace from L to M to K, okay, that's only part of that angle right there. And I see that it's going to be an alternate interior to the 68. So I'm actually going to fill in 68 degrees for this angle here. And then the last one it's asking for is it says angle LJM. So if I go LJM, it's going to be this angle over here. Okay. Some things that we can fill in. Since we know the diagonals are congruent, we can mark these as congruent. And just a reminder from yesterday, that means this triangle right here is isosceles. So if 2 sides are the same, that means 2 angles are the same. I can also fill out 68 degrees right here. However, that's not the angle they're asking for. They're asking for the one right here. So I need to take the idea of the 4 angles of the rectangle are going to be 90 degrees. So I'm going to go 90 and subtract that 68, and we're going to be left with 22 degrees for that missing angle. Okay. On number 4, it says if PQRS is a rectangle, find the measure of angle QPT. So if I kind of trace for us, we're going from Q to P to T. We want to find that angle measure. They don't give us any information there, but what I do see on this diagram is I have this 16x minus 17 and this 10x plus 1. Those are alternate interiors, so we're just going to say 16x minus 17 has to equal 10x plus 1 and solve for x. Okay, we do that by subtracting the 10x, and when we subtract 10x, what's left over? 6x minus 17 equal to 1. I need to add the 17 to the other side. We're going to end up with 6x equal to 18. So when we divide by 6, we're going to find x is equal to 3. So we still haven't solved the problem. What I could do from here is I could substitute that value in to either of the angles. So if I go up here, I'm going to go 10 times 3 plus 1 10 times 3 would give me 30, and 30 plus 1 would give me 31 degrees, which means I have a 31-degree angle right here. Using that idea that my rectangle has 4 right angles or 4 congruent angles, what I'm going to do is I'm going to say 90 minus the 31, and it looks like we're going to be left with 59 degrees for that missing angle that they asked us to find. Okay, so that was review of rectangles. Now we're going to move into properties of rhombi. Okay, a rhombus is still a parallelogram, so it's going to have all of those parallelogram properties that we talked about. Okay, so you could fill these in on your own. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, meaning that they equal to 180. And then the last one is the diagonals bisect each other. Okay, the new pieces for a rhombus, how many of these can you remember from yesterday? All of the sides are congruent, and it's actually already marked on our diagram for us. Okay, the diagonals are going to be perpendicular. And perpendicular means that we are going to get these 90s around the middle, which they already have one marked for us. We could mark the rest if we want to, but if we know we have one 90-degree angle there, the rest of them have to be 90. The last one is going to be the diagonals bisect the angles, or on here it says the opposite angles, okay? That means that these are going to be congruent and these will be congruent, and then I can mark 2 arcs on the other pieces and they'll be the same as these 2 angles over here. Okay, so applying those properties of a rhombus. Here we go. It says if WXYZ is a rhombus, find each measure. So when we look here, first thing it's asking for is XY, and XY is one of the sides of the rhombus. One property of a rhombus is all of the sides are the same. So XY is going to measure 27. Okay, WP is part of a diagonal. WP is right here. It matches up with this diagonal over here, so it should be the same as that measure, and we're going to put in 21. The next one's going to be PZ, and PZ is going to be this special piece right here, and we don't have any information there, so some things that we could fill in. If we want to work with just this triangle, okay, we already know this side right here is 21. We could fill in Y to Z to be 27 because all of the sides of a rhombus are congruent. We're going to use that property that the diagonals are perpendicular to each other so that we can find that missing segment right there. We're just going to call it X for right now. Okay, and you're using your Pythagorean theorem that we reviewed yesterday. So this would be X squared plus 21 squared equal to 27 squared. Okay, so I'm going to get X squared plus, I believe, 21 squared is just 441. Sorry, trying to find my calculator. Okay, so 21 squared is 441. And then 27 squared, I get 729. From there, I need to subtract the 441, and I'm left with X squared is equal to 288. And then my last step would be to take the square root of 288, and it's going to come out to be a decimal. I got 16.97. So for this one, I'm going to say approximately 17. Okay. Now we're going to work with those angles. So if I erase some of our side work here, okay, the first angle that it asks me to find is the measure of angle XZW. So if I trace here, XZW is going to be this angle right here. Since the diagonals bisect those angles, this is just going to be 51 degrees. The next one says angle XWZ. So if I trace it, XWZ, it's going to be this full angle right here. Now, we're going to work with what we call those consecutives, or those same side interiors, okay? All of this angle Z, it would be 51 plus 51. Which is going to measure 102 degrees. Okay, so this whole angle Z is 102. All of angle Z and all of angle W together have to equal to 180. So I'm going to go 180 minus the 102. Angle W is going to measure 78 degrees. Okay, and then the last one that they're asking for is angle ZYW. So if I trace ZYW, okay, what they have here is we just found this full angle to be 78, and since the diagonals bisect the angles, we're going to take 78 and divide by 2. And if I go 78 and divide by 2, I'm going to end up with 39 degrees for that angle. Okay, on the next example, it says if EFGH is a rhombus, find the measure of angle FGE. Okay, so angle FGE is just going to be part of it. Okay, multi-stepped. So we're going to say that these two angles that are provided are congruent to each other. So I'm going to say 8x minus 49 has to be equal to 5x minus 7. Okay, if I subtract the 5x from both sides, what am I left with? 3x minus 49 equal to a negative 7. Okay, from there I need to add 49 to the other side. And I'm going to end up with 3x is equal to 42. Okay, from there if we divide by 3, we're going to find our x value is equal to 14. Okay, so finding the measure of angle FGE. Well, we're going to have to substitute this value in. So I'm going to plug it into this top angle right here. I'm going to go 5 times 14 minus 7. 5 times 14, I believe, is 80. Oops. Just kidding, it's 70. 5 times 14 gives me 70. And then I go 70 minus 7. So this angle is going to measure 63 degrees. Okay. Now, kind of hard to see, but that's this angle right here. Okay. What I could do from there is I could say, well, my diagonals are perpendicular. That's going to give me a 90 right here. And then if I think about this triangle has to measure 180 degrees. If I add the 90 and the 63, I get 153 degrees already in that triangle. And when I subtract, I'm going to be left with 27 degrees for the missing angle. And that would be our final answer. Okay, you could also use your consecutive interiors. Find the measure of this whole angle, subtract from 180 to get this whole angle G, and then divide by 2. Okay, last one, property of squares. Good review. Here we go. So a square has, we know the most information about a square. It has all of the properties that we've talked about so far. They're going to fit on the screen just barely. Okay, so all of the parallelogram properties. The opposite sides are parallel. The opposite sides are congruent. The opposite angles are congruent. Maybe you could say these along with me. Consecutive angles are supplementary, meaning that they equal to 180. Okay, diagonals bisect each other. Okay, I know it's going to have all right angles because a square is made up of a rectangle. All of the sides are going to be congruent. That's the property from a rhombus. The diagonals are congruent to each other. The diagonals are also perpendicular, which means they're going to form 90-degree angles in the center. And then the diagonals will bisect the opposite angles. Okay, so we know a lot of information about this square. We could fill in these 90s here. We know these are all 90s. We also know that the diagonals bisect those angles, which leaves us with 45s down here and then all the way around. And we also know that these diagonals are all congruent to each other. Okay, so lots of things that we know about a square. Example problems, if BCDE is a square, find each missing measure. Okay, so let's see here if it let me, okay. So it's asking me to find CE. We know that the diagonals bisect each other. So if this is 8, then down here has to be 8. What's our length of C to E? It should be 16. BC is going to be this side right here. Ooh, kind of tricky. Let's use that Pythagorean theorem again. Okay, so we've got a right angle right here. The sides of these triangles are 8. Okay, remember the hypotenuse has to go at the end. So we're going to say 8 squared plus 8 squared is equal to x squared. It's going to give me 64 plus 64 equal to x squared. Now I have 128 is equal to x squared. If I take the square root of both sides, what is the square root of 128? You guys are probably faster than me on your calculators. So square root of 128, I got 11.3. Boom, boom, boom. Okay. Next angle it asks me for is angle CFD. So if I trace for you CFD, well, it's around the center, so it's got to be 90 because the diagonals are perpendicular. The last one says angle DBE, and we kind of talked about this on the last slide. If this angle is 90 degrees, but the diagonal bisects the angle, when I cut it in half, I'm going to end up with 45 degrees for that missing angle. Okay. Last problem for today. Here we go. It says if QRST is a square, find QS. Okay, well, what can I fill in here on my square? I know this side is 21, which makes this side 21. This angle's 90. They want me to find this missing piece right here. We're using that Pythagorean theorem one more time. Okay, hypotenuse is still the x for this problem, so we're going to say 21 squared plus 21 squared is equal to x squared. Okay, 21 squared we had earlier today, it's 441 plus 441 equal to x squared. When I add those together, it's going to give me 882 equal to x squared, and my last step is to take that square root. Let's see here. 882, the square root of 882 comes out to be 29.698, so I'm going to say it's going to be approximately 29.7 centimeters, and that's our final answer. Okay, for today you guys are going to work on worksheet number 3, and you guys are going to do the odds today, so the odds for your assignment. See you soon. Bye guys.